The demand for hybrid components continues to grow in all applications of electronics. The hybrid's ability to provide the custom integration of virtually all types of active and passive components into a minimum area fulfills the system designer's greatest need: high-performance circuits that occupy less space. Hybrid scale integration allows the interconnecting of custom and standard devices from all available technologies into a functional microsystem. This packaging capability offers solutions to many design problems, including lower cost through higher performance, better system integration through custom packages, increased functions through combining device technologies, better performance through faster speed, as in VHSIC applications, proprietary protection through hybrid enclosures, higher reliability through fewer interconnects. In the majority of applications, cost is a prime consideration. Hybrid users improve their cost to selling price ratio by adding performance into a smaller area. Also, due to its relatively short design cycle, the hybrid allows the user to bring his higher performance circuit to market quickly. This combination of lower cost and quick market penetration improves the user's competitive position. Complex systems designed into a fixed space pose difficult integration problems. The hybrid package offers several solutions. Obviously, the reduced size is number one. Another asset is the flexibility and custom nature of the hybrid package. The system designer has many alternatives when using a package that has flexibility in size, shape, and pinouts. Custom hybrids can combine analog and digital ICs with other discrete active and passive components into a single functional circuit. This ability to integrate all device technologies is a powerful design tool, allowing the designer greater flexibility in his high-performance, small-size design. As more circuitry is being offered on a single chip, faster system speeds are possible. Due to its inherent short lead lengths, the hybrid supports this possibility. By combining the speed-sensitive devices into a hybrid package, circuit speed is not degraded, as in separate packages interconnected on a printed circuit board. Higher performance circuit designs are what make one system better than another. The need to protect the integrity of these new designs is a major consideration. Interconnecting uncased standard and custom devices with a miniature substrate and encasing that assembly into a hybrid package helps assure the proprietary aspects of the circuit. The reliability requirements of all electronic systems are severe. This important requirement is enhanced with the use of hybrid circuits. When reliability engineers apply their MTBF, mean time before failure formula, to a new circuit design, a key question is how many interconnections are required to allow the components to function as a completed circuit. Chip and wire hybrids require fewer interconnections than an equivalent discrete version. This fact, coupled with the ability to test many components as a functional unit, improves the circuit's reliability before and after it has been assembled into the final system. To fulfill these needs, hybrid producers such as Hytek employ extensive facilities, equipment, and processes in the design and manufacturing of these powerful components. Obviously, the design phase of hybrid implementation is critical. Due to its custom nature, the user has many choices to satisfy his particular application. It is during the design phase that the user and the hybrid designer optimize the hybrid design. It is at this time the following questions are answered. What are the circuit performance requirements? Does the circuit need to be as small as possible? How soon are prototypes needed? How soon is production needed? What quantities are anticipated? Is the circuit design complete? What type circuit is required? Analog? Digital? Combination? RF? Power? What are the passive component characteristics? What are the active components characteristics? What is the availability of the components? What are the voltage and current considerations? What type of package is required? What are the environmental considerations? What are the test requirements? Is special screening needed? Once these questions are answered, the hybrid designer can utilize one or more of the following implementations: custom analog or digital integrated circuits, custom standard cell integrated circuits, custom analog or digital gate array, surface-mounted assemblies using off-the-shelf small outline devices. SMD. Custom hybrid circuit utilizing standard die. Hybrid circuit utilizing a combination of custom and standard die. All of these microelectronic choices can be packaged in hybrid form. Which approach is selected depends on the particular application and its needs. Once the design approach is selected, the user should be concerned with the hybrid producer's capabilities in the areas of design, manufacturing processes, process control, and quality assurance. At Hytek, all hybrid designs are accomplished utilizing CalMA and Hewlett-Packard computer-aided design systems. These systems are dedicated to design, artwork generation, and documentation. Beginning with the electrical schematic and specifications, the designer, with the aid of specific programs, will design the hybrid including the layout and component placement. The color graphic monitor enables the designer to select a program and visually verify traces and layering. Design guidelines programmed into the CAD interact throughout the design process to ensure accuracy is being maintained. 10 times artwork is required for each layer. Often as many as 12 layers are required to produce a hybrid circuit. Each layer is plotted directly from the CAD, ensuring accuracy and repeatability. The detailed drawings required by manufacturing are plotted directly from the CAD using liquid ink for color. For security and documentation, all designs are stored on magnetic tape. Once the hybrid designs are in artwork form, the manufacturing process can begin. Each hybrid layer is photographically reduced from its 10 times rubylith to 1-time film. The film is exposed on metal screens, which serve as the vehicle to print the various thick film inks required to produce the hybrid substrate. At Hytek, the thick film processes are accomplished in a Class 1000 clean room. Complex multi-layer substrates are printed beneath laminar flow hoods, which provide a Class 100 environment. High-volume products are manufactured on a fully automatic cartridge-fed system, which includes a printer, dryer, and furnace. The multi-zone furnaces are used to fire the thick film materials at temperatures ranging from 500 to 1000 degrees centigrade, causing a permanent exchange of molecules between the ceramic base and the thick film materials. The furnace internal environment is air, except for copper material, which requires nitrogen. The dew point is closely controlled to -100 degrees Fahrenheit. After firing the substrates, all resistors are laser trimmed to the final values. Hytek's laser resistor trim operations employ 6 automatic trimmers, capable of trimming 1 million resistors per day. Also, complex hybrid circuits often utilize functional or active trimming to achieve optimum performance on such parameters as offset, common mode rejection, gain, or pulse width. It's common for hybrid producers to print substrates multi-up, as an example where multiple prints are applied to a common ceramic, as in the semiconductor industry. This wafer approach improves both the output and cost of the substrate process. At Hytek, multi-up substrates are scribed into individual parts, utilizing a 500-watt CO2 laser. This powerful laser scribes ceramic at a rate of up to 10 inches per second. Also, by utilizing this laser's boring head system, holes in any shape or size 10 thousandths diameter or greater can be drilled through the ceramic. To assure the availability of the many different semiconductors required to produce hybrid circuits, some hybrid manufacturers have wafer processing capabilities. At Hytek, wafer probe, saw, and pick and plate equipment are utilized to process purchased semiconductor wafers and the gate array wafers designed by Hytek. This process also allows for the correct die placement into waffle packs required for subsequent automatic die attach operation. The automatic die attach process consists of correctly placing semiconductors and ceramic capacitors onto substrates. The substrates have previously been printed with epoxy onto the die attach land areas. Substrates are cured at 150 degrees centigrade to complete the die attach operation. The resultant precise and consistent location of the semiconductors supports the following operation: automatic wire bonding. A typical complex hybrid circuit requires 100 wires or more. Automatic wire bonding not only is faster, 10 times faster than manual wire bonders, but assures that each wire is correctly placed. This and the wire bond strength consistency makes for higher yields and more reliable product. Hybrid circuits are 100% electrically tested several times throughout the manufacturing process. The electrical test operations, detailed visual criteria, and other screening operations are needed to produce a reliable product and to monitor the hybrid manufacturing processes. Hybrids, like other components, are tested and screened at several levels depending on the final application. Commercial applications that will see a room temperature environment require less testing than military or automotive applications that need to perform in harsh environments. The hybrid producer and the user will select tests and screens for the appropriate application. Quality programs are required to assure the reliability and design requirements of the customer's application are satisfied. Hytek is in full compliance with MIL I 45208, military specification for inspection systems, and test equipment calibration per MIL standard 45662. The government recently established MIL Standard 1772, which defines the requirements to be a supplier of military hybrid circuits. Hytek's Carson City facility was certified to MIL Standard 1772 on February 25, 1987. Both Carson City and Los Gatos inspection standards, process control, and general documentation benefited from the MIL Standard 1772 government audit. Virtually all electronic markets have recognized the benefits of hybrid circuitry. Custom circuitry for the military, functional modules for telecommunications, ignition and control units for automotive, external and implantable circuits for medical, networking circuits for data processing, custom modules for computers, pin electronics for automatic test equipment. In these and many other applications, hybrid circuits are acknowledged as the best solution to microelectronic packaging puzzles.